So this discussion is going to be to kind of introduce what we mean by operational amplifiers, or often just sort of for short called op-amps. They're a circuit element that is kind of steeped in the way we talk about linear circuits and linear circuit lore and in circuits in general. These are devices that were kind of sort of elements that have been talked about for 70, 80 years now, built in, initially as something that would be the size that you would hold something the size of a football, built with vacuum tubes, and eventually now where they're just ubiquitous everywhere across a whole bunch of structures. So the whole concept of an operational amplifier is a structure that takes a differential input voltage, takes a difference between two voltages somewhere, V plus and V minus, and basically gains that voltage up by a pretty high number, which in this case we'll call A sub V, and that voltage is, could be anywhere technically 300 to a million, but usually considered to be big enough you don't think about it. And it has sort of a lore to it and sort of a core structure to kind of many things we build. It has this sort of symbol, this triangle symbol, and a couple of things will have different forms of triangles. But you'll see where it has a plus terminal V plus and a V minus, and some output voltage then to ground. If you want to look at it in a sort of circuit model element, one way that you would model it is you have V plus and V minus, no current getting pulled between those two terminals. So it doesn't have any loading whatsoever. And based on the difference of that voltage, I'm going to gain up that voltage, and that's going to be sitting at the output. And you think, well, okay, makes sense. It certainly gives a justification for why we talk about a voltage-controlled voltage source. This structure gets thought about in multiple ways, one of which is as just a high gain amplifier. One way to think about it is that, and we'll talk about this in a few other times, is it feels like an integrator. And basically it has a high gain, but that's at very low frequencies often, or lower frequencies, but we might just approximate and say it's a high gain everywhere. So, and that's typically the starting model when you start with this, when it's this kind of structure. Now, there's one other piece of lore that's really important, and I kind of want to make this clear right from the beginning. One of the things that'll happen is we'll take these amplifier structures and this op-amp and put resistors around them. And that term will often be called feedback, because we'll often take the result of the output voltage and it might connect back to the minus terminal or a plus terminal, or might do different things that kind of changes the way the behavior of this structure works, or the overall circuit works, and that's going to be a really useful thing. One of the things we'll notice is that this structure will make sense when this output voltage sits inside of a power supply rail, because in the end you still got to power these things, so you're not getting anything for free, and you usually have to put some sort of power supply rails to make this work, maybe 0 volts and 5 volts, 5 volts and minus 5 volts, and you'll notice this if you actually get hold of a discrete op-amp. You'll see this structure. Well, if that output voltage has to stay within the power supply rails, say plus or minus 5 volts, so there's a 10 volt swing, say my gain was 100,000, well, that means that these two voltages here, V plus and V minus, are going to be pretty close to each other. In fact, they're going to be within microvolts, within 100 microvolts of each other. And for a lot of different circuit applications, that looks like they're almost identical. And so a lore often happens the way we do the analysis with these circuits is to say, the inputs, when we put it into a lot of different circuits, we kind of start assuming the inputs are equal. V plus and V minus are identically the same voltage. And yet there's no contact between them. So they're the same voltage, but but they're not connected. And sometimes people look at this and go, that's just magic. Some people go, oh, that's just something I need to memorize. Just put in my memory, and that's one other thing I need to memorize. But either way, I think you can get into confusion unless you realize the reason you get it, the reason you make that approximation is the fact that I'm really trying to keep a voltage in the power supply rail. And as a result, this has to be very, very tightly constrained. So the way that my circuit is going to be operating forces that condition. And so we'll see this used in multiple ways and in multiple circuits. But I wanted to kind of introduce what you generally see here. And there's so many neat things about it, and there's so much lore about these circuits. And so it's really important to kind of be comfortable and familiar with these ideas.